Hi everyone. In this video, we're going to look at transformations of trig functions. Now, let's say I had a graph of y is equal to sine x, and I wanted to apply different transformations to my graph. Well, these letters here, my a value, my k value, my d value, and my c value represent different transformations I could apply to my graph. My a value, for example, here, tells me my vertical stretch, or my vertical compression. If my a value is greater than 1, that's a vertical stretch. And if my a value is between 0 and 1, that's a vertical compression. And if my a value is negative, then we just flip the graph upside down. Or in other words, in mathematical terms, we can say we reflect the graph in the x-axis. Okay, what about my k value? Well, my k value tells me my horizontal stretch, or my horizontal compression. If my k value is between 0 and 1, that's going to be a horizontal stretch. And if my k value is greater than 1, that's going to be a horizontal compression. And if my k value is negative, then we just reflect the graph in the y-axis. My d value here, well, if inside my brackets I'm adding some number to x, then that means we move that number to the left. And if I'm adding some number inside my brackets, if I'm subtracting some number from my bracket, that tells me we move that number to the right. And finally, my c value at the end, well, my c value tells me how much I go up or down. If my c value is positive, or in other words, greater than 0, we go up by c. And if my c value is negative, or in other words, c is less than 0, then we go down by c. And there you go. Those are the different transformations I could apply to my graph. And just a couple things I want to note before we look at some examples. My a value here tells me what I have to multiply my original y values by. So, if I had a graph of y is equal to sine x, and then I put an a in front, my a value would tell me how much I need to multiply my original y values by to get my new y values. I'm going to write that in this form, just to indicate that. My k value, on the other hand, tells me how much I would need to divide my original x values by. We're going to take a look at some examples of this to see what I mean here. Okay, let's say I wanted to sketch a graph of y is equal to sine of x minus pi over 4. Now, I'm going to start by sketching a graph of y is equal to sine x. Then apply a transformation to sketch my new graph. First, let's start by sketching a graph of y is equal to sine x. Whenever I'm sketching a graph of y is equal to sine x, I always like to go up or down by pi over 2 on my x-axis. Just because I find it's a really convenient scale to use. Okay, and now I'm going to include a scale for my y-axis as well. And now, whenever we're applying transformations to the graph of y is equal to sine x, it's important to know some of the points that are on my graph of y is equal to sine x. And these are some points it will be helpful to memorize when you're graphing transformations of y is equal to sine x. So, here's one point. When x is equal to 0, sine of x is also equal to 0. When x is pi over 2, sine of x is equal to 1. When x is pi, sine of x is equal to 0. When x is 3 pi over 2, sine of x is equal to negative 1. And when x is 2 pi, sine of x is equal to 0. So there you have it. Right? There you have your graph of y is equal to sine x. And of course, I can continue my graph on the left-hand side here as well. Sorry, let me fix my graph. Okay. Now, I want to graph y is equal to sine of x minus pi over 4. Well, now, let's identify what transformations I need to apply to my graph to get my new graph. Alright, sine of x minus pi over 4. Well, I'm subtracting by pi over 4. I'm subtracting pi over 4 by x. And since I'm subtracting inside the brackets, that tells me I need to go to the right by pi over 4. So each point on my graph of y is equal to sine x, I'm going to need to shift right pi over 4. And here I can tell. Okay, so on my graph, if I go 2 boxes to the right, 2 boxes equals pi over 2 radians. That means 1 box on my graph, 1 box to the right will be pi over 4 radians. So I'm going to need to take each of my points and shift them 1 box here to the right. Right, since that's equal to pi over 4 radians. And there we go. And of course, I can extend my graph. But there you go. There is my new transformed graph. Okay, let's take a look at a couple more examples. So, say I had y is equal to 4 sine of 2x plus 1. Again, I'm going to start by identifying, and thinking about what are some of the different transformations I need to apply to my graph. Okay. There's a 4 in front of my sign. Again, since the number in front is greater than 1, that means we're applying a vertical stretch. Or in other words, I'm multiplying the y values of my original graph, sine x, by 4. Also, there's a 2 in front of the x. This tells us, since this number is greater than 1, there is a horizontal compression here because the value is greater than 1. And the number in front of x tells us what I need to divide my original x values by. And finally, at the end here, we have a plus 1. So, at the end, I'm going to need to shift all of my points up 1. Also, an important thing to note, when you're graphing sine or cosine functions and transformations, you always want to apply any vertical stretches or compressions or horizontal stretches and compressions first. Right? You always want to apply any stretches or compressions before you apply any translations to the graph. Okay, let's get to graphing now. So we looked at, in the previous example, we looked at some points of y is equal to sine x. Now, we can apply these different transformations to my original points, and that will give me my new points on the graph. First, we're going to multiply our y values by 4 and divide our x values by 2. Well, if I divide my x values by 2, well, first, 0 divided by 2 is going to become what? 0. Again, we can keep going. We're just going to start by dividing our x values by 2. Look at the next one. Pi over 2. If I divide that by 2, I get pi over 4. Here, if I take pi and divide that by 2, I get pi over 2. And we can keep going. Right? I'm just going to divide all of my x values by 4. Next, I need to multiply my y values by 4. Here, my y value is 0. 0 times 4 gives you 0. Next, I have a y value of 1. 1 times 4 gives you 4. Here, I have a y value of 0. Again, we're just going to multiply that by 4 to get my new y value. And I'm going to keep going. I'm going to do the same thing for the other examples as well. And finally, I need to shift my y values up 1. Or in other words, I need to add 1 to my y values. So, I'm going to take my y values here and add 1 to them. Okay, 4 plus 1, that gives you 5. 0 plus 1, that's going to give you 1. Right, and we're going to keep going. And there you go. And now that I know the points, right, I know the points of my transformed graph, all I need to do now is I just need to sketch those points on my graph. And then I'm done. So let's do that. On my graph, I'm going to increase my x values by pi over 4. Since these points are increasing, the x values are increasing by pi over 4. So it's just a convenient scale to use. All right. And my y values, I'm going to go up by 1. All right. And now all I need to do is I just need to plot my points. Okay, so I'm just going to plot my points. Okay, so I'm going to plot the points 0, 1, pi over 4, 5, pi over 2, 1, 3 pi over 4, negative 3, pi 1, and we can extend our graph further if we want here. But this is how our graph is going to look like. Okay, one more example. But this time we're looking at our graph of cosine and applying some different transformations. Okay, let's identify what transformations we're applying to a graph of cosine. And then we're going to do a similar something similar to what we did in part B to help us figure out our values. Okay, so here, the number in front of cosine is greater than 1. So that's a vertical stretch. Or in other words, we're multiplying our original y values by 2. Okay, the 4 here, the 4 is greater than 1. So what does that mean? We're applying a horizontal compression. Or in other words, we divide our original x values by 4. And finally, we're going to go, okay, since we're subtracting by pi over 4 inside the brackets, we're going to go pi over 4 units to the right. Okay, just like in part B, I'm going to write down my original points. And something to note here, since we're graphing cosine, it's going to have different points than our sine graph. I'm going to write down the points you'll need to know for the cosine graph. Right, these are points that are good to know when you're graphing transformations of cosine. So that should be a positive one. All right. And now all we need to do is we're just going to apply these transformations, right, to get our new points. Okay, let's start by dividing our x values by 4. Next, we're going to multiply our y values by 2. And next, we need to shift our graph pi over 4 units to the right. Pi over 4 radians to the right. Now, on our graph, okay, shifting it right pi over 4 units. Well, on our graph, we're going to go further to the right. So on our points, we need to add pi over 4 radians to our x values, right? We need to add pi over 4 radians to x because we're shifting our points to the right on our graph. So each x value, so this one, for example, 0. Well, if you add pi over 4 to 0, we get pi over 4. Okay, next one. If I add pi over 4 to pi over 8, well, I can check. Okay, well, if I add those together, I get 3 pi over 8. Okay, and I can keep going, right? I can add pi over 4. Okay, if I add pi over 4 to pi over 4, I get 2 pi over 4, or pi over 2. If I add pi over 4 to 3 pi over 8, well, let's do that up here. I'm going to get 5 pi over 8. And if I add pi over 4 to pi over 2, again, I'm gonna do that. I'm gonna do that up here. Okay. Well, and if I rewrite this, so it has a common denominator, and then if I add these together, I get 3 pi over 4. All right, and there we go. Right, so those are our new points. So let's graph them now. Okay, just looking at this, a good scale to go up by on my x-axis is pi over 4. Right, that seems like a good scale to go up by on the x-axis. So let's do it. And let me fix that. Okay. And now for my y-axis, well, my y values, I can just go up by 1. Okay. And now I'm just going to plot my points. Okay, 3 pi over 8 should be somewhere between pi over 4 and pi over 2. Okay, pi over 2 and negative 2. Okay, 5 pi over 8 should be between pi over 2 and 3 pi over 4. And we have our last point here, 3 pi over 4 and 2. And there we go. And of course, you can extend this, right? You can extend the graph. You could keep going, right? And you can extend the graph further. But that's the basic idea, though, right? That's the basic idea when you are graphing these graphing different transformations of trig functions, right? So you take your original points, right, for either your sine graph or cosine graph, and then you apply the different transformations to the points to get your new graph, right? To get your new points and to get your new graph.